Hello students, day 4 online classes. Welcome back once again. Today I'm going to teach you composition of functions. The definition of composition of functions is given in NCERT book, which I have exactly copied here. F is a function from A to B and G be a function from B to C are these two functions. Then the composition of f and g together, it is not addition or multiplication, it is f with respect to g or g with respect to f. F and g denoted by gof is defined as a function gof is from a to c. By reading the definition, it's so difficult to understand, but see how it looks like. This is set A undergoes with a function f to set B. Then from set B to C there is one function which is G. This is set C. Then according to the definition, GOF is a function from A to C. Okay, this is GOF is a function from A to C such that G of f of x can be written as G of is a bracket f of x for all x belonging to A. X belonging to A, x is the domain element, this is the domain set, this is codomain for what? Gof. Okay, f and g are two simple functions you can take and see the example. Let me show you practically how it works. Let us take set A as 1, 2, 3 and 4. It undergoes a transformation with a function f, and this f of x, what can be the simplest function? Say 2x. So x takes the value 1, 2, 3, 4. So f is a function from a to b. 2 into 1 2, 2 into 2 4, 2 into 3 6 and 2 into 4 8. Fine. Let us take one more function which is g of x. Okay, and this function goes to the set C. Now we can take any function as g of x. Say this is x plus 5. Fine. Now the domain of g of x, x takes the value 2, 4, 6, 8. 2 plus 5, I get 7. 4 plus 5, I get 9. 6 plus 5, 11. 8 plus 5, 13. Okay. Now your GOF, according to the definition, GOF is a function from A to C, isn't it? GOF is a function from A to C. Now what we can do is, let us check GOF of x. Okay. GOF is also a special function made by the composition of fx and gx together. So what is that function? We will find it out. G of f of x is g of f of x. Now you can do, what is g of x? G of x is x plus 5. So it is, in place of x, I need to write fx plus 5. Now what is fx? Fx is 2x. So 2x plus 5. Now you can see GOF is a function, special function 2x plus 5. And this GOF has its domain set as A and codomain set as C. Let us check whether it is correct or not. If I take GOF of 1, if I write GOF of 1, what do I get? 2 into 1, 2 plus 5, 7. GOF of 2, if I put 2, 4 plus 5, 9. 9. This means what? This GOF is such that GOF is such that it is from A to C, where A is its domain set and C is its codomain set. This is what the definition says, the composition of functions. Now, what is the use? Where do you use this composition of functions? Let me tell you that this composition of functions is utilized to find FOG, that means a new function, or say GOF. Let us take one example. Say f of x is the simplest of the form x square. I am taking very simple examples because I don't want to confuse you. And g of x, let us take g of x as sine x, cos x, whatever you want to take. I am taking sine x. Let us take one more function, okay? And the function is h of x. H of x. I have taken quadratic, I have taken trigonometric function. Now I want to take modulus, okay? Mod x, modulus function. Whatever is coming in my mind, I am just doing it, okay? Now see, I want to find FOG, fog, okay? If I want to find fog, then I need to write FOG of x. FOG is equal to FOG of x, which is equals to f of g of x. You can write like this. Okay. Then we will, what we do is, what is f of x? F of x. F of x is x square. So in place of x, we write g of x. This is f, this is x. What is fx? X square. When it is gx, it is gx square. When it is t, it is t square. When it is n, it is n square. So when it is gx, it is gx square. So gx whole square. And what is gx? Gx is sine x. So I get sine x whole square. And it is all about sine square x. Now you can see FOG is a function made out of fx and gx, and the function is sine square x. Similarly, let us try one more. GOF of x. I want to find GOF, GOF. What is GOF now? This can be written as G of f of x. Very simple. G of f of x. What is g of x? G of x is sine x. So sine, in place of x, you write f of x. Okay? In place of x, you write f of x. Now what is fx? Fx is x square. So replace it by x square. Sine x square. So it's so simple, see? Now there lies other functions also. Like I can use h of x also. Say FOH, for of x we are finding, okay? So it is f of h of x. In this way there are 3, okay, and at a time 2, so 6 different functions we can find using the composition of 2 functions. So f of h of x, what is h of x? But first, what is f of x? F of x is x square. So x ke jagah pe we can write h of x, and it is whole square. X square. What is h of x? H of x is mod x. Mod x, and it is square. We know that mod x, in my previous class I had said that is a positive function, and the square is also a positive function. So no need to write mod, it can be written as x square. The last one for your practice, okay? Let us write HOG, hog of x, okay? Hog of x. So it is h of g of x. Fine? H of g of x. So what is h of g of x? H of g of x is, what is h of x? H of x is mod x. So mod, what is g of x? Right inside Fine. So what is g of x? Sin x. So write mod sin x. So when I am solving it, it looks like a child's play. When you start trying doing this, I know to start with it will take a little time, but once you understand, get a grip. It is scoring. And at home you can try two more are there. GOH is not done. Okay, so that also you can practice. And there are some questions in the exercise also to find. Let us try one such from the exercise. Okay, NCRT book exercise 1.3, exercise 1.3 NCRT book. This is your NCRT book exercise 1.3. I have a question. Question is find GOF and FOG. Okay, they're asking find GOF and FOG if f of x is how much? F of x is 8x cube and g of x is x to the power 1 by 3. Very simple. Let's try this answer. What I will do is I'll find first FOG. FOG of x. Fine. FOG of x can be written as f of g of x. Fine. So f of g of x means, what is fx? Fx is 8x cube. 8 in place of x you write gx and it is cube. In place of gx I need to write x to the power 1 by 3. So it is 8 x to the power 1 by 3. Outside cube I get 8x. This is what? So simple, isn't it? And if I have to find GOF of x, GOF of x is g of f of x. You try, see, you can try yourself. What is f of x or what is g of x? G of x is x to the power 1 by 3. X to the power 1 by 3. G of x. G of x is x to the power 1 by 3. What is x? X is fx. Fx to the power 1 by 3. Fine. Now what is fx? Fx is 8x cube. 8x cube to the power 1 by 3. 8 becomes 2. 2x is the answer. So there are very simple questions, okay, in the exercise. There's one more question, question number 4. I will wipe it off, then I will write. Is it fine? This was question number 2. Question number 4. Question number 4 says, if f of x equals to, exercise 1.3, if f of x equals to 4x plus 3 by 6x minus 4, x is not equal to 2 by 3. So that show f of x equals to x. Okay, and what is the inverse of f is also asked. I have not started invertible functions, so let me conclude till here only. Fine. Now f of x is 4x plus 3 by 6x minus 4. What we do is f of x. Fine, answer. Here, fine. And one more thing, to understand this question completely, you need to know why x is not equal to 2 by 3. X cannot take a value 2 by 3 because if I put 2 by 3 in the denominator of fx, 2 by 3, 3 2 is 6, 2 2 is 4, 4 minus 4, 0. Denominator becomes 0 and the function do not exist. So the function will not exist for 2 by 3. That's why x is not equal to 2 by 3. It's given. Okay. So I'm finding f of x. So I can write 4 in place of x. We write fx plus 3 by 6 fx minus 4. So what do I get? 4. What is fx? 4x plus 3 by 6x minus 4 plus 3, 6, 4x plus 3 by 6x minus 4 minus 4. Take the LCM, simplify, your answer will be there. 4 4 16x, 4 3 is 12 plus 12, 6 3 is 18 plus 18x minus 12 divided by, I am taking the LCM, 6x minus 4. This is also 24x, 18 minus 24x plus 16 divided by 6x minus 4. This is getting cancelled. I am getting 12 12 cancelled, 24 24 cancelled. 18 plus 16 is 34. 34x by 34. What do I get? X. So what is f of x? F of x is x itself. So final answer is very important. F of x is the x itself. Becomes, maybe whatever is the input, the same comes as output, becomes an identity function. Okay. So in this way you can always use FOG, GOF, HOG. In this way you can always use composition of functions, right? There are some properties of composition of functions also. The properties are like, yes, let us see some questions, okay, which are examples or the theorems, okay, in the book. The questions are, let me write. The question says, show that question 1, okay, show that if f is from a to b, and g is from b to c, are 1 1, are 1 1, then they say, then GOF from A to C is also 1 1. Then GOF, which is from A to C, is also 1 1. Not difficult to prove. The reason is F is 1 1, G is 1 1. I need to prove GOF is also 1 1. So our old strategy, whenever we prove 1 1, what we do? GOF of x1 equals to GOF of x2. Let x1 x2 belong to set A, because GOF का domain set is A and codomain set is C. So G of f of x1 equals to G of f of x2. We can write. We know that the function g of this and g of this, function g is 1 1. G is 1 1 means what? What we used to do is, for 1 1, if you have seen my previous video, I have shown you that for 1 1 function, if I can take f of x1 equals to f of x2, implies x1 equals to x2. F is 1 1. This was the previous concept video. Okay. So here also, g of x1 equals to g of x2 means what? x1 equals to x2, because g is 1 1. as g is 1 1. Now again f is 1 1, so this implies x1 equals to x2 as f is 1 1. So which proves that GOF of x1 equals to GOF of x2 means x1 equals to x2. So GOF is 1 1 function. Fine, so simple to understand. Next one is, let us try one onto question also. Okay, so where I have a book. Okay, there it is. Show that f is from a to b. This is number 2. Okay, these are little technically different questions, you can understand. So that f is such that from a to b, g is such that from b to c are onto. Instead of 1 1, they are writing are onto. Then GOF from A to C is also onto. I need to show that. Okay, how do I show this? So let us wipe everything, because this is the question which we are going to think about. And I have to prove that from A to C it is also 1 1. So let us take that figure, no? A, B, C, A, B, C. A has X, B has Y, Z has C. When we say onto, means all the elements of this set C have at least one image in set B, then it is onto. So what we do is, let Z belongs to C, and we know that this is function G, this is function F. If Z belongs to C, and it has been given that G is an onto function, so we can write G of Y equals to Z. G of Y will give me Z, and at the same time F is also onto, so F of X is equal to Y. F of X equals to Y. Now you can understand, if I put f of x, I get y, and if I put g of y, I get z. Then I can check GOF of x. So if I can see that all the elements have its images, or all the images have its pre-image, then it is onto. So GOF of x is g of f of x. What is f of x? F of x is y. G of y. What is g of y? It is z. So this means what? For every x there is z, or for every z there is its pre-image x. Therefore GOF is onto function. Fine. So this much for the composition of functions. In my next video you will understand and try yourself how to find inverse of a function. Actually, last day, if you have not forgotten, in the last video I have already shown you that if the function is 1 1 and onto, then the function is bijective. If a function is bijective, then it is invertible. And how do we prove that the function is invertible in a different way using composition of functions? That I am going to teach you in my next video. See you then. Bye.